Hello, welcome back. So in this video we will do a small hands-on on polynomial regression. So far we have been doing linear regression. So how if our data is biased or if our model is biased, we can do a polynomial regression, and we will check how we can do polynomial regression. So here I have already created and opened a notebook and written few instructions beforehand. You can watch my Python background video in session 1 part 2 on installation of Python and how to create a notebook. You can just go to your command prompt or your Anaconda prompt after you have installed Anaconda and type Jupyter notebook. From the directory you move into the directory where you want to work on and create Jupyter notebook. You get something like this. You get a browser. From here you can create a new notebook, or if you already have some notebooks, you would find it over here with an extension IPYNB, and you can work on that notebook. Okay, so I have made the initial imports and have created data for polynomial regression. It is the same data, marks and the predicted salary. Okay, and I have converted the data into a data matrix using NumPy array. Okay, I pass the data, which is an array of tuples. Okay, so let's execute these instructions. Okay, and first we will start with linear regression and draw the regression line on it. I'll show you. Okay, so linear regression, this we have already done. Okay, this time we are just doing it on an univariate. I have also done it earlier. Okay, and fit and data map, we need to pass all rows in column 0 and need to reshape it because it's one dimensional, and the target variable data mat all rows in column 1 and reshape it to -1, 1, and this has a double M. I hope no others. Okay, that's great. Okay, so from here we get the we are trying to fit a line mx plus c, so we get m and c and we can find the equation of the line, right? So Euler dot coefficient Euler dot coefficient. Okay, so you see we have one coefficient, so this is our m. Okay, so if there were if we had multivariate, we would have found multiple here, and c is Euler dot intercept. Okay, so I think that also I need to take it from an array. Okay, it's also an array, so I take the 0th element, and here I'll take the 0 element because it's two-dimensional array. Okay, and let's see m and c. Okay, and something's not right here. I think it's 1 0. Okay, now it's okay. So m is 71 and c is this. Okay, now our equation, let's define a function, get line function, and if we pass x here, it would return us mx plus c. I hope you are getting familiarized with Python as well. It would pass m into these are global variables. Even if I don't pass, the function would get it. Okay, not a very good way of programming, but for now it's okay. Okay, now I'll create a list of okay, my x is in the range of 800 to 975, right? Okay, so I will create np dot arrange 800 to 900 let's say a difference of 5, and it returns an arrange bit dot arrange. I think it's 1R. Okay, so this is my x val, and I can do, okay, I think I can do it in one go. Dot plot, so my x values, and I pass my x values in the get line font. Let's see if it works, otherwise I have to do it in 2 steps. The corresponding y values will be passed, and here I have, okay, yeah, I have the line. And let me also print the dots also over here, so that the dot plot, and let's do a scatter plot now. The dots to print only dots. Data map 1, so x and y values. Here I have imported this to create this scatter plot, and you saw I used linear regression and numpy. Just a quick check at the imports. I'll use polynomial features later. Okay, so yeah, okay, so here why is my line so short? Okay, I had x values beyond, so let me create it from 750, say 750. Okay, but you see the lines are like this. Can I fit a line like this? This is more or less a reasonable line, but actually it could have been like this. So for that I need to consider this as a polynomial equation. So x, I have considered this as a linear equation, like mxy equal to mx. Let me write it down how I am considering this. Mark down. Okay, I have considered y equal to mx plus c, but let's think of it like y equal to mx square plus m1x square plus m2x. This is square plus c. This is for a univariate. Had it been x and y, it would have been x square xy plus y square. But don't worry, we don't need to bother that much about it, because we have this function in Python, polynomial features, and we can pass a matrix and it will raise its variables to polynomials. Okay, so I will create a new x equal to this one, and what is my polynomial? Okay, I pass my transforms showing me matrix, so I will make it 2-dimensional. Okay, polynomial features, it doesn't take this, it takes the dimensions. I want to raise to the power of 3. You can raise it to the power of cube, anything you can do. And now x here I will do, okay, x. So here I mentioned the degree while initializing the variable, and then I use a fit transform to raise it. Okay, so now let's see x. It's like now this is for the bias term. This is x square plus x. Okay, so it works here. Okay, now we will do a linear regression. We will use the same Euler to fit this new x. Okay, and we will not pass our previous x values, we will just pass x. Okay, so it fits these 3. Now it behaves like a linear regression, only I have created variables. Okay, this is x squared, this is, okay, this is x and this is x squared. If you see, I think this is the square of this one. Okay, now let's see. So I have, now let me get the coefficients. Okay, okay, it should return me 3. You can ignore this because we will get the intercepts. This is for x square and this is for x, or the vice versa. Let me see. Okay, m1 equal to, so it's a two-dimensional, it's the 0th array, and then again the sorry, it's 1. This is 0, this is 1, this is 2. So take 1, and I'll also take m2. I'll take 2. Let me print. Let's see if I have taken it correctly or not. Okay, cool. That's correct. Now let me also take C. C is the intercept, and we know how to get it. Okay. Now what should be my function? My function now if get polyline, and when I pass x, I have to return square. So I return this one into x plus this one. I'm assuming the second one is the square. Let me see. Printed the data, removed it. Okay, let me check out x a bit for that. I think this is the square. Yeah, second one is the square. So first parameter plus, okay, I don't need to do this. I have m1 plus m2 into x. So m2 into x square, and this is how you do a square in Python with double star plus c, and our function is ready. Now we will do the same stuff. We will create some points from 750 to 900 with a gap of 5, and those will be my x's, and calling the polyline function on it will create my y's, and I should have my line here, and the polynomial line it should be, and there, and I will also print the scatter plot of my x and y to see it all together. Let's see. Okay, so this looks great. So you can see this is now a polynomial line, and it has fit all the points almost closer than my linear points. Okay, but this might not be a good idea to do a polynomial regression. As I mentioned in my linear regression video, this might cause an overfit. So overfit is, it is fitting every points in the training data that I have, but maybe when a test data comes, it might be somewhere over here. So these may be actually outliers in attempting to fit my line over these points. I have actually done an overfitting. So I have to be very cautious with a huge amount of data. I have to do a bias variance trade-off. I have explained how to check that, how to see whether it's a bias or a variance, and then we should decide on whether we need to do a polynomial regression. So hope you enjoyed the video on polynomial regression. Okay, and keep subscribed for more videos. Thank you.